right? And here, heading into second semester, I've decided I want to try to get you thinking a little bit more, try something a little bit different. And so before we start launching into like some new stuff, I want to see how well you can use what we've done before, and also kind of taking a bigger look at this. So this isn't just a matter of, hey, what are the techniques we've learned? This is just in general, how many different ways could you solve this problem? And yes, I want you to think of anything that you can think of, any way that you could figure out how would you find this derivative. Now, at this point, as I've been walking around, I've seen most of you have found the derivative using one particular method. But remember, the goal here is to see how many different ways can you find that derivative. Notice the question I did not ask here was, what's the right answer? I did not ask, what is the derivative? But rather, how can you find that derivative? How many different ways can you find it? This is not a way that we're used to thinking about these sorts of problems. That's why we're doing it. As I've been walking around, I've been able to start seeing what you all are coming up with. Now, most of you, based on just sheer number, as I've been walking around, most of you have done it just straightforward, where you've just plugged this into the quotient rule. And by plugging it into the quotient rule, that meant that you also ended up doing a little bit of chain rule with that part and stuff like that, right? Is that the only way you could do it? Not by a long shot. And so when we talk about that first method, this is what I saw most people writing on their paper. Now, that's not to say you still can't use quotient rule and come up with another method. But this is the way most people thought about it. Just take it exactly as it is, plug it into my rule, and go from there. Yes, this is one method, but there are lots of other methods as well. So we talked about kind of that first, most straightforward one where you just take it exactly as you see it and you just plug it in the quotient rule, plug and chug kind of method there, right? But there are many different other methods. So what's another method that you've come up with here? And so I actually heard two different things we could use in there. Because one thing that you were talking about there was that we could actually, it's all the idea of simplifying. The first step of simplifying is that we could go 48 x to the 8th over 16 x to the 6th. Okay, so that's another method right there, is we could turn into that, and then we could again use quotient rule. But then you took us even further, where notice that that fraction even simplifies. And I could even simplify this. So the 48 over 16 equals 3. X to the 8th over x to the 6th is x squared. And we could find the derivative of that. So there's three methods right there. Okay. Other methods. So, if I was going to find the derivative of this one, we talked about how we would have to use the quotient rule if we just did it straightforward, but there you're talking about how we could even rewrite that in another way, or we could turn this into 48x to the 8th times flipping that 16x to the 6th to the top. That would mean that whole thing would then be to the -1. Now, a little side note on that one. Notice that would not be the same as 16x to the -6, because that would only move the x up. We need to move the whole 16x up. So we could do it that way. Yeah. We could also then go, instead of just doing quotient rule straight from this first one, we actually could have done the same kind of thing where we did it here, where we could turn this into 48x to the 8th times 4x cubed to the -2. We could also do that then. Now, this is certainly not an exhaustive list, but this certainly covers a lot of the stuff that we've talked about in class, where basically the quotient rule, we've got this one, this one, this one. So we've got at least 5 methods right there, right? Now, as you look up those and see them, you're probably thinking one of them is maybe easier or preferable than another. Your idea is probably different than a lot of other people's ideas about which method they prefer. So be thinking about which method do you like for any given problem, and that's just kind of a starting point. You can do these other ways. But now, I really want to do this activity because I want to try to get you thinking outside of the box as much as possible. And so, what if I gave you this sort of problem and you really were not sure what to do? Like you had no idea even how to start it. How else could you then go and find the derivative? Yeah, so breaking out of the kind of normal in-class box, yeah, we could say, okay, well, I could go onto the internet. Okay. Now, what does that mean? There's a lot of possibilities, right? So, like, what are some resources that you might use if you went out on the internet? Photomath, Desmos. We could check out a textbook. It's not internet, but that's an option.
No.
Yeah, I know, weird, retro, right? What else on the internet is a good option? Or at least a valid option. We aren't necessarily making judgments here.
Encyclopedia.
I think I heard Mathway. Yep, you could Google it and see what Google said. Or other search engines like Bing, whatever.
Yahoo Answers? That one? Google Reddit. Go on Reddit. Make your own subreddit.
Derivative calc. And I actually heard a few different ones that kind of fall under the same umbrella. I'll just put them all under the same one of message boards. Like people will throw stuff like that out on Reddit or something like that, which isn't necessarily the best way to do it because you never know what you're getting back in return, but it's a valid way. It can work. You just got to be pretty smart about it. Oh, there's a weird idea. You could ask a teacher. Or really any other expert. Of course, your math teacher should be an expert in how to do it, but I mean, if you knew an engineer, you could ask the engineer or any other expert. Yeah, other classmates. You could use your resources from within your actual math class. So, for many of you, when I first put up this problem and first said, okay, how many different ways can you come up with, what I saw overall was about 80% of you came up with this. I can just plug it into quotient rule and I can go from there. Are you starting to see how maybe that's limiting our thinking a little bit? Because there are so many different ways. And is this an exhaustive list? Is this everything we could come up with?
No.
No, not by a long shot. There's tons of other ways that you could go about doing this. For instance, nobody thought of saying, I can take my 4x cubed squared and rewrite it as 4x cubed times 4x cubed and use the product rule with it. Things like that. There's all sorts of other ways that you could approach this and get creative. Now, some of you might have had that one, but I didn't hear it. So there are lots of different ways that we can go about these types of problems. And I want you starting to think creatively about this. How can you go about doing some of these types of things without just locking yourself into a box of the same old? Because, yeah, we as math teachers have kind of created this little box that we think as math students we have to live in. But I'm wanting to break you out of that. All right. And so then, this was kind of our fun activity to start class. We do have one other activity that we need to go through today. We're going to be finding the derivative of inverse sine of x. So please write this one down, and then we're going to start taking a look at how we can approach it. So here we're going to be finding the derivative of y equals inverse sine of x. Now, we don't know this derivative right now, okay? And so when thinking about it, yeah, we could think back to, okay, what do I do when I don't know? And we remember we came up with that list about all the different things we could try. You know, we could go on the internet, we could ask someone, stuff like that. But I do want us to be able to actually be able to find it ourselves and know where this comes from. And actually I want to show you how we get it, because I could just give you a rule, but what fun is that? And so, first of all, I want to rewrite this in a form that I can actually deal with. Now, that -1 here, what does that -1 mean? Yeah, it means inverse. Please note, inverse does not mean 1 over sine of x. It does not mean that. That would be sine of x to the -1. That's how you'd have to write that one. That's the one where you wouldn't actually be allowed to take that -1 and put it in there because it means the inverse. And so, no, we can't just turn it into that. But I do know what the derivative of sine is. So if I could rewrite this using sine instead of inverse sine, then we could do it. So how can I rewrite this equation a little bit differently then? Well, what if I was trying to solve this equation for x? I could get rid of the inverse sine there, right?
Yeah.
What would I do to both sides? What undoes inverse sine?
Logarithm.
Not logarithms, no. Sine undoes inverse sine. So I could do the sine of both sides of the equation. Now notice that I have sine of y equals x. Now this now looks like something that we do know rules for. It's just a matter of actually using it. Now as a side note, technically this is only true for being within a certain certain range here, but it's still actually going to be valid for everything else we do, as you'll see. All right, so now that I've gotten to this point, I can now actually take the derivative. Now, we couldn't have done this before we did our implicit differentiation, but now we can. So go ahead and take a moment. Please write out what is the derivative of that going to equal. All right, so on the left side, when we do that derivative, the derivative of sine, of course, is cosine. And it's going to be cosine of the same thing. So it's going to be cosine of y. But notice that since it's y, not x, yes, you do need to use chain rule here. So that will be times y prime. And then that will equal the derivative of x, which is
1.
all right. So we now found the derivative. I still want to be able to figure out what y prime equals. So I'm going to try to get y prime by itself. So that means dividing both sides by cosine of y. Okay, great. I now have y prime equals. There's just one little issue that I have with this particular equation. Valid as it is, usually when we have a rule, we want to be able to get down to a rule that says if y equals inverse sine of x, then y prime will equal this. And usually this does not have y in it. Normally it's all just x, right? So we need to get a little creative now. We need to figure out how can we do this. Well, this is where we have to get a little bit tricky. Because if this were a sine of y instead of a cosine of y, then we could actually do something with it, right? So how can we change that part of our equation to involve sine instead of cosine? So, you know, last year you learned a lot of those trig identities, right? Well, most of them don't come up very often at all, but one of them does. One of those comes up a whole lot. Sine squared plus cosine squared equals 1. We could use that here. I could figure out what cosine equaled, right?
Yeah.
Because we could like subtract the sine squared of x from both sides, and then I could get rid of the squared by like taking the square root of both sides, right? And so I could get rid of the cosine by using that particular trig identity. That's why that is such a tricky move there. And so if I blew your mind a little bit there, this is what we're really doing. Is we just took that sine squared plus cosine squared equals 1, and we solved it for cosine, and then we were able to replace that in our equation. So I just took that and put it into the bottom. All right, now that we are here, we again can use what we know. Because remember, I wanted it in terms of sine because I know what sine is. Remember that sine of y equals x. So down here in my equation, where I have sine of y, I can replace that sine of y with x. And so we then are able to boil it down to an equation that is y prime equals this in terms of only x. Notice we no longer have to deal with that y sitting in there. It's just in terms of x. And I think it's important to see why this one works the way it does, because it seems very counterintuitive that the derivative of inverse sine would not even involve a trig ratio at all. But that's the case. Now, of course, we just showed then how we can find the derivative of inverse sine. We've now found the rule for inverse sine. In fact, we could proceed and do the exact same thing for all 5 other inverse trig functions. I'm not going to make us go through the derivation of all of those derivatives. Instead, I'm just going to tell you, go ahead and get out your derivatives notes and go ahead and add all of our inverse trig derivatives to the derivative rules. Now, of course, we will be using these going forward, which means you're going to need to know these. You got them in your notes so you'll be able to reference back to them. But I want you getting to know them as soon as you can. And so, let's talk a little bit about how we can memorize it. Little things you can look for that are going to help you to memorize it. First of all, remember when you just learned the derivative of sine, cosine, tangent, cosecant, secant, and cotangent. Remember there are a few rules there where a lot of stuff was very similar. Like for instance, you might recall that there, all of the cotangents, cosecants, cosines, remember all those derivatives were negative. Notice which ones are negative here. So if I look for all the negatives here, again, go with all of the cos. So if it's a cotangent function, or any of the other ones, it's going to be a negative when you do that derivative. So already that's a hint. That's something you can look for as a way to memorize it. Basically, that just meant that you went down from memorizing 6 different things down to 4 different things, 3 formulas and 1 rule. Then, other things we can look for. Notice they all are fractions. They all have the x's in them and the x squareds. The trickiest part with these is really memorizing what the different denominators are. So focus on just remembering that these are the various denominators, and then once you know what they are, then you can start worrying about where to apply them and which one it goes with. And look for other little rules that you might find there. This can be a little bit tricky. And I do want you to hopefully have these memorized by the end of this week. So that's a couple days of class time to get there. We're going to have the rest of class today for you to practice using these. And again, be thinking about how you're going to do that, because you'll notice that the quiz at the end of this week, it's going to be a fairly simple and straightforward quiz, because it's going to be done without your notes.